Hello, class. Today we are talking about something that relates to this image. So for the warm-up, what do you notice? Well, maybe the fact that there are two ugly frogs, as one student said, reflected in the water. That's the main gist. For what we're going to be talking about today is reflections. We want to find the reflected image and write the rules of reflection. So you can see the objectives today and right at the bottom in the highlight area. So that's our objectives down below, and it's day 1 of 1. So we're only spending 1 day in here before we're continuing on. Warm up, ready to that. Vocabulary, discussion, have a couple of examples, and could go from there. So today for vocab, what we should be seeing is, for review, it's image, line of reflection, reflection, transformation, and the new vocabulary is rigid motion. And as you see right here, we see that rigid motion is a transformation that preserves length and angle measure. So if you look at this image over here, it's not really rigid motion because the sizes are different. So this angle measure is the same, but the length is not. As you see, it's right there, not the same. So it's not a rigid motion. For here, we have an example of rigid motion. It's either the top two or the bottom two. So just go ahead and pause, give it some thought, and come on back. Welcome back. Well, if you said that it was the top two, you would be 100% correct because they are just rotated. Reflections, the book way. Reflection is a transformation that reflects the points across the line or reflections, and we're using midpoints to make up the line. You see that all that stuff has to go through all that fun stuff. That's the way the book wants you to do it. So we have congruence here. So the line is made up of midpoints. So it's the same congruence on the other side, and then we have another set of congruences. The little area, a little t on the A means prime. You can have A prime, you can have A prime prime, A prime 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 prime. Doesn't matter how many primes you have, you just keep on adding more, basically, of those. Reflection. Notice the capital R. The easy way. We're going to reflect across the y-axis. That is y is equal to 0. When y is equal to 0, that means we're just going along the x-axis. Sorry, the x-axis. So we first draw a line. It can be imaginary if we have a graph. It's like, okay, if I'm reflecting there, what do I need to do? How about we count to that line and keep going? There's an easier way than this, but this is just showing exactly what we're doing. So notice that the A point dropped by 6, E by 2, D by 1, B by 5, and C by 2. So we're going to keep going by that same amount. In other words, we're going to drop A even more by 6, E by 2 more, D by 1 more, B by 5 more, and C by 2 more to get our new shape, A prime, B prime, C prime, D prime, E prime. What changed? Did X or Y change? Notice that A prime is at X of one value, B prime, and A is at X of one value. So it's the Y term that changed. So reflect across the Y-axis, okay? So when we reflect across the Y-axis, we just draw a vertical pole right at 0 through the origin. So same process. We draw that vertical pole in, and then we count draw to there if we have to. So we have to move D, C, B, and A, but E's right there on top of it, so it doesn't need to move at all. So we count A by 2, B by 2, C by 3, and D by 5. And we continue on by that same amount. And draw our new image. Notice that E, which was on the line of reflection, didn't move, but the rest did. What changed? Y values stayed the same, but the X values swapped the sign. So this is a new thing we're going to be doing, checkpoints, where you would just let me know which one you guys think it is and go from there. So if we're reflecting y is equal to 0, think of what that is. That's going to be across the x-axis. So what would change is the question. X stays the same, y changes. So you should be looking at -2. A reflection on y is equal to x. When we have for y is equal to x, what we have is something different, but it's always a good idea to write that line. Same as previous, but we want a perpendicular line. So draw in the early line of reflection, and then we just kind of count to it. For instance, we see that B has to go 1, 2, 3, 4, A and C just by 1. So we count away at about that same amount. 1, 2, 3, 4, and 1 and 1. There's our A prime, B prime, and C prime. And we draw the image. What changed? B went from 8, 0 to 0, 8. C went from 4, 2 to 2, 4. A from 6, 4 to 4, 6. So notice that they only swapped. So when we have a negative x, we do the same thing, but we just have a negative graph. All right, so we have a negative graph now. What do we do? Count to. Even if it's just like a half point, we still count by that half. Okay, so for instance, set D is just going to go up to that 1, 0 from its negative 1. So we're just going to redo the process, but starting with A. A should sound from there because it went from 2.5, drop by 2.5. B is going to go by 2.5, drop by 2.5. C, D, and E. So by reflecting the image, we get something that looks kind of like that. All right. So if we're reflecting across y is equal to x, remember what happens. It's a positive. So all we need to do is swap. These are the common types of reflections you're going to get. We see that beforehand we get xy. After, for about the x-axis, it's x, negative y. All we're doing is change to y. xy, negative x, negative y is equal to x, you just swap. Y is equal to negative x, you swap and take the opposites. All right. So finding the line the book way. Note it's not a common line. That's what that uncommon line means. All right. So an important formula to use would be the midpoint formula. x1 plus x2 divided by 2. y1 plus y2 divided by 2. All right. Let's go. So you need to find a point and count in. How about D? 0 and 1. So we plug that in. 0 plus 1 divided by 2. 0 plus 1 divided by 2 gives us 1/2. 1/2. Draw that line up, point on in. Then we have 0. How about C? 0 and 3 and 4 and 1. 0 plus 4 divided by 2 and negative 3 plus 1 divided by 2. That says 4, 2, negative 2, 2. 2, negative 1. Draw that one on it. Then it wants us to go ahead and draw this line from the midpoints. So we draw that line. All right. Now what kind of line we have? Well, we can use midpoints, and he wants us to then get the slope from using it this way instead of using an easier way using logic. So we have 1/2 minus 2, 1/2 plus 2, or plus 1. Convert those 2's and 1's into halves, so we have 1/2 minus 4/2 and 1/2 plus 2/2, getting us negative 3/2 above 3/2. Negative 1 divided by 1, negative 1. But that should be logically easy to see from the graph that we drew, from the line we drew. Then we plug into point slope. So we have y plus 1 using one of our points, the negative 1, 2 we used, and negative x plus 2. This is easier the counting way, as I call it. How about instead we just count across? For instance, A, 1, 2. Divide that by 2, pop the point in the middle. C, 1, 2, 3, 4. Divide that by 2, pop in the middle. Draw that line. Clearly looking at it, you see that we have a slope of 1, up by 1, over by 1, up by 1, over by 1, up by 1, over by 1. Find the midpoint, intercept 0, 3. Y equals mx plus b becomes x plus 3. So this will be the final checkpoint for the day, if you guys were in class. Which of the following equations of the line is a reflection? You would hold the finger and it matched in your choice. Some people got snotty with them at, but that's besides the point. But the main thing you want to look at is count from B to B prime. B, drop by 1, 2, here at the x-axis, 3, 4, 5, 6. You get to the B prime. So 6 divided by 2 is 3. So count down by 3 from 2. That's going to be negative 1. Why is negative 1 is your line of reflection? Your homework would have been page 324, numbers 19, 21, 24, 28, 33, and 34.